Okay, so we talk about attribute based encryption. There we will see how we can use the attributes to encrypt. So this is a basically public key encryption setup, public key PKE setup. So in public key, what we have seen, it is a basically one to one. So we have a public key generation center, so which give us the public keys, or we can have a I mean every users is having its own public key private key pair. So while encryption is done using the public key of the users on the message and send it to the public channel, this ciphertext, and this message will be recovered by the decryptor, and each decryptor is having the public key and the corresponding secret key, and then using the decryption algorithm on the ciphertext using the secret key or the private corresponding private key of the users get the message. So this is one to one correspondence. So this is the then we discuss the identity based encryption scheme, where this is also one to one correspondence, but here we don't need to maintain any public key directory. We can just use the ID as a ID of the ID of the users as a public key, and to get the this ID could be email ID, biometric, I mean our fingerprint could be the ID, I mean like this with thumb impression, or our retina, it could be the ID. So any biometric or any email ID, so this should be the unique identification, I mean our PAN number, so our email ID. So any unique identification can be used as a ID of the users. So in this identity based encryption scenario, we use the users is having his own ID. So user will send the ID to the key generation center, and the key generation center is having a this is at setup phase, having a parameter, public parameter, and the master key, and this master key will be used to generate the secret key of the users, and this key generation center will send the secret key of the users. So ID and this ID is public key and the SK is the secret key. So basic difference is basically identity we are using as a public key, and the encryption is by similar way. We take the suppose this is Alice, this is Bob. Alice wants to send a message to Bob. So Alice will need to get the Bob's public key, but now here public key is basically ID. So Alice not Bob ID. So Alice will use Bob ID along with the public parameter need to use, and generate the ciphertext CT and send it over the public channel. Now Bob is having Bob's secret key SK. So Bob will decrypt this by applying the decryption algorithm, and can get the this message which is sent by the Alice. Now this was earlier every scheme was the one to one scheme. So now this is basically for one to one scheme we have a difficulty to, suppose we want to send a message, so that only the legitimate users will able to decrypt it. So for that so one to one will create some problem, because the bandwidth will be more, because we have to send to everybody. So in that way, so this attribute based encryption is basically one to many. So basically it is a fine grained access structure. So here the scenario is every user has a credential of the user. So suppose we are talking about student database, user is a student. So that student is MA mathematics, MA means mathematics department student or math student, and MSc, the student is enrolled as a MSc student. Okay. So this is the L is the credential of this user. Now this user will send user's credential to the key generation center, and the key generation center at the setup phase it's having the public parameter and the master key, and using it will send the secret key for this credential. So SKL. So, it will send the secret key with that credential of the users. Now, the attributes are basically departments, the MA, computer science, ITE, these are the attributes. Then the course which is enrolled, like whether it is PhD, MTech, MSc. So, these are the basically designation of the student. So, whether MSc enrolled. So, now we want that encryption should be done if this attributes is satisfied. This attribute means the student should be MA and the student is either PhD student or MSc student. So, we want to broadcast a message so that we want to broadcast a message so that only those students which is having satisfying these attributes. Attributes is basically the student is mathematics department student and student is a PhD student or student is a MSc student. So, this is the attribute. So, if these attributes is satisfied, then the student should able to decrypt it. So, this has many applications in this cloud computing system. So, we put our data in the cloud in an encrypted way. So, now we want that some group of students should able to see the data. So, suppose we release the marks of the students. So, now we release the marks of the MSc mathematics MSc students, the mark sheet, I mean like the roll list and this. So, we will use this attribute based encryption. So, we broadcast this ciphertext, we encrypt it and we broadcast it, but we only allow those students who are mathematics student and MSc, they should able to see the they should able to decrypt it to see their marks. So, this is the attributes we are giving. So, if these attributes satisfied by the users, then he or she only should be able to decrypt it. So, that is the idea. So, here this W is the basically MA and this. So, we encrypt the message using this set of attributes W and this generate the ciphertext and this we broadcast over the public channel. Okay. Now, this is the cluster of decryptor, this is the group of users U1, U2, UN. So, this is say U3, they have the credential like MA, MSc. So, these groups should able to decrypt the message using their secret key based on that credential L. So, this secret key will be received by the key generation center based on their attributes, I mean their credential. Okay. So, this has good application, as I said, in cloud storage application, tolerance network, wireless sensor network, mobile ad hoc networks and internet service. We may talk few more in details in the later lectures. Okay. So, now this is another one to many which is broadcast encryption. So, in broadcast encryption what we have? We have a group manager or this or the the group manager or some say for cable operator we have a group dealer, I mean we have a dealer or the group manager and there are some users and users is having some secret keys, some secret SK1, SK2, SKN like this. So, now a user how they got this secret? The user UI will send the identity of its to the group manager and group manager send the secret SKI to the user I. So, then this is the set of users, universe of the user. Among these, say S is the active user. So, few user can be revoked. So, R is the set of revoked users, few users could be revoked. Say suppose for example, if it is cable, if it is some TV service provider, some cable operator. So, there are few users who are subscribed for this channel and there are few users who stop paying. So, those are basically revoked users. So, those are basically set of revoked user, but still there are some users which are active users, that means they are not revoked users. So, they are the legitimate user. So, they should able to decrypt the encrypted channel information or encrypted movie. So, that is the idea. So, here S is the active user and R is the revoked user list, and so so that the encryption will be done in this way. Either two possibilities are there, two ways we can do this broadcast encryption. The first one is we can use the set of active users in while encrypting and generate the ciphertext and send it to the and broadcast it, and this is the group of users. So, among this, if UI belongs to the set of active user, then only UI should be able to decrypt it. So, this is one way, or we can use the set of revoked user list R, and we generate the ciphertext using the set of revoked user list, and this we broadcast the ciphertext over the public channel, and only the users which are not revoked user should be able to decrypt it using its own secret key. Okay. So, this is the broadcast encryption. So, we will see some scheme of this broadcast encryption. For that, we need to use this bilinear map. So, just to recap, so let G and GT be two multiplicative cyclic group of order P, and P is a prime. So, E is a map from G cross G to GT satisfying the following property. First property is E u to the power A v to the power B should equal to E u v to the power A B, because u to the power A means u times A. So, A is belongs to ZP. So, e to the power A is belongs to G, and similarly v to the power B will also belongs to G. So, E u to the power, so this we can operate E on this, because E is a mapping from G cross G to GT. So, we operate this. So, this should be equal, this is the bilinearity property, and if G is a generator of G, small g is a generator of capital G, then EGG should be the generator of GT. So, that means EGG should not be equal to the identity element of GT, and EUV should be efficiently computable. So, that means there should exist a polynomial time algorithm to compute EGG. So, there should exist a practical example of compute of this EUV. So, for example, Tet pairing or well pairing from elliptic curve are basic two example of this bilinear map, but this involves the algebra like divisibility theorem, all these things. So, we are not for this course, this is not in our syllabus, but we will only use the concept of the bilinear map in a theoretical way. So, we are not going to the details of construction of this EUV, but this is two example. If you have interest, you can look into the details of this, but it needs some math background. Okay. So, let us come to the identity based encryption scheme by Bonnet-Franklin, which was published in Crypto 2001. So, this we have already discussed. So, just to recap. So, here this is G, GT, and small g is the generator of G, and P is a prime number, E is a bilinear map, and this public parameter is P, G, Q. Q is basically G to the power alpha. So, alpha is the master key, which we will use for generating the secret key of the users, and H1 is the mapping, H1 is the hash function which take the any arbitrary input and generate a element in G, and H2 is a mapping a hash function from which take a element in GT and give a 0 1 bit of length L. Okay. So, this is the ID based encryption. So, user sends the ID to the PKC public key generation center or key generation center, and using this public parameter and the master key. So, this PKG will send this H1 ID to the power alpha as the secret key of the user, whose ID is ID. So, now the encryption is this way. So, this is the ciphertext C1 C2. So, we generate a random number r from the ZP. So, we compute g to the power r, and C2 is basically, this is the message. So, C2 is basically XOR with this H2 applied on this E H1 ID q to the power r, and this is basically C1 and C2. So, this C1 C2 will be send it to the receiver. Now, receiver will receive, the receiver is having also public parameter is public, and receiving having this secret key which is basically H1 ID to the power alpha, and is getting the ciphertext CT over the public channel. Then receiver can decrypt this by just applying C2 XOR with H2 ESKID comma C1, because this basically will give us this C2 is basically message XOR with this, and now if we just calculate this H2 of this H2 of E of H1 ID comma q to the power r XOR with H2 of E of H1 ID to the power alpha g to the power alpha. Now, we can use the bilinearity property of this. So, it will be basically alpha r, and similarly this will be also alpha r. So, these two will be cancelled out, and we will be getting the message this thing. So, this is the identity based encryption we have seen. Now, we will talk about attribute based encryption, where this is Sahai and Watered. So, this is basically called fuzzy identity based encryption. Why fuzzy identity based encryption? Because suppose we are using the identity as a biometric. So, our fingerprint. So, our fingerprint means it has some characteristics over here. So, based on that, I think 40 characteristics are there. So, based on that characteristics, it uniquely determined our fingerprint. So, suppose we have some card in this some card or something. So, maybe all characteristics are not matching. So, suppose few are matching. So, even though we should able to decrypt it. So, that means there is a threshold. So, that is why it is called fuzzy identity based encryption. So, we have some threshold of it. So, that threshold, that if d many characteristics are matching in the fingerprint, then we should able to decrypt it. So, that way. So, this is basically a case of attribute based encryption. So, let us talk about Sahai and Watered attributes based encryption. So, this is basically having this setup phase, we choose P, G same way, and these are the attributes. So, 1, 2 up to n. So, these are basically those 40 characteristics of the fingerprint, like which uniquely determine the fingerprint, we can say. Okay. And these are the public parameter P, G, E, G2, then H is a hash function we use, and Y is basically E, G, G2 to the power alpha, and this T1, T2, Tn, where T1 are basically randomly chosen from the G. So, they are the element from G which is randomly chosen, and alpha is a randomly chosen from ZP, which will be the master key. Okay. So, this is the master key. So, now what we will do? We will send a credential. So, user will send a credential L to the center group KGC key generation center, and key generation center will send a SKL to the users. This SKL is basically L comma this D1. D1 is basically G to the power R, D2 is basically G2 to the power alpha, H1 to the power R, Di is basically Ti to the power R. These Ti's are basically randomly chosen, and this where R is also a randomly chosen from ZP. So, this is basically secret key sent to the user. So, if we use this credential in the encrypted form, so if they are coming together, it should able to decrypt it. So, that is the idea of attribute based encryption. Okay. So, this is the encryption part. So, in the encryption part we need to use the public parameter. So, these are the public parameter, and this is basically the message we are going to encrypt. So, message belongs to GT, and this is the ciphertext. So, ciphertext has few component W, C1, C2, C3. So, C1 is basically we just give the message dot y1 to the power s, sorry, y to the power s, C2 is basically g to the power s, C3 is basically this h of this to the power s, and this s is randomly chosen from this ZP. Okay. And this decryption is basically, for decryption we also need the public parameter and the SKL. SKL is the secret key, the received from the this key generation center upon the sending the this credential of the users, and with the ciphertext CT by just using if this I1, I2, IL is belongs to L, this credential, or it is not a subset of L, then decryption must fail. But if it is subset of L, so that means if our finger among the fingerprint, if d many characteristics are satisfying, then it should able to decrypt it. So, that means we are allowing a that is why it is called fuzzy identity based encryption. So, we are giving a threshold, the threshold is this IK. So, IK is the threshold. So, if it is satisfied, then we should able to decrypt it. So, this is by decryption is just by simply C2 into E D1 C3 divided by E D C3 C2. So, this is the correctness of it. So, we have this secret key and we have the ciphertext, and then we generate this, then why we know this. So, if we just calculate this, it will be giving us E g comma g2 to the power alpha s because of the property of bilinearity, and E g to the power r h of this will give us basically, this is again because of the bilinearity property, then these two will cancel out. So, it will give us the messages. Okay. So, this is the Sahai and Water scheme, but this is basically attribute based encryption, but it is basically used for fuzzy identity based encryption, where we are allowing some threshold in our identity. I mean, like we said fingerprint identity. So, if the fingerprint is not completely matching, so we are allowing some characteristics to match. Among the 40 characteristics, suppose 30 characteristics are matching of the fingerprint, then we should able to decrypt it. So, that is the idea, and this paper will come to this paper got accepted in Eurocrypt. So, this is the paper Sahai and Water. So, this is the paper fuzzy identity based encryption paper. This paper got accepted in Eurocrypt 2005. Yeah. So, there is another scheme which is broadcast encryption scheme with revocation, but this is we are not going to include in our syllabus. So, this is the paper, and if we have this broadcast encryption scheme, we are not including in our syllabus. Thank you.